Okay, when you're dealing with probabilities, key words to bear in mind are when you're using the word or and when you're using the word and. If you are using the word and, then that means that you're going to be multiplying probabilities. Okay, so and means multiply. And if you're using the word or, then that means you're going to be adding probabilities together. Now let's take a look at the context of this first question. We've got a bag that contains 7 blue balls and 5 green balls, and a different bag containing 4 blue balls and 6 red balls. A ball is drawn at random from the first bag and its colour is noted. A ball is then drawn at random from the second bag and its colour is noted. And the way that this is shown on the diagram here is that the first bag is this first pair of branches here, and in the bag there are 7 blue balls and 5 green. So the chances of you getting a blue ball are 7 out of 12, because there are 12 balls in the bag, 7 of them are blue. So as far as green is concerned, the chances of you getting a green one will be 5 out of 12. So that's the chances of what you're going to get from the first ball. The second ball is taken out of a different bag, and the second bag has got 4 blue balls and 6 red balls. So there are 10 balls in the bag altogether, so the chances of you pulling a blue ball out would be 4 out of 10, and the chances of you pulling a red ball out would be 6 out of 10. And this is repeated in this branch down here because we'll look at this branch if the outcome of the first ball coming out was green. So again, this is the second bag. Chances of it being blue are 4 out of 10, and the chances of it being red are 6 out of 10. So calculate the probability that both balls are blue. For the both balls to be blue, then that means the first one is blue, which has got a chance of 7 out of 12, and, so there's the keyword, and the second ball is blue. So the probability that both balls are blue means first blue and second blue. Okay, so the first blue is 7 out of 12, and means times second blue 4 out of 10. Now when you multiply fractions, you multiply the top numbers, 7 4s are 28, and you multiply the bottom numbers, 120. So the probability that both balls are blue is 28 out of 120. And you could cancel that down, you could turn it into a decimal, but leave it as it is. It sometimes makes the rest of it more straightforward. Now, calculate the probability that at least one ball is blue. Now, for at least one ball to be blue, that could mean first blue and second red. Or it could mean first green, second blue. Or it could mean both blue. Okay, so there are 3 different possible combinations which will satisfy at least one being blue. Okay, so it's that and that multiply, or add that and that multiply, or both blue, which you've already worked out. Now sometimes what some people do is they do all the anding on the diagram anyway. Okay, so this one here would be blue and blue, which would be what we've already worked out, 28 out of 120. This one would be blue and red, which would be 7 times 6 is 42 out of 120. If I go this way, it's green and blue, which is 20. 5 fours are 20 out of 120. And this one is green and red, which is 5 sixes are 30 out of 120. So we've done all the anding. If we end up there, it means the first ball is blue and the second one is blue. If we end up here, first ball blue and second one red, and so on. So this probability here, first blue and second red, is 42 out of 120. Or means and, remember, green blue 20 out of 120, or both blue, which we've already worked out to be 28 out of 120. Now when you add fractions, you can only add them once the bottom number, the denominator, is all the same, which it is in this case, and you don't add those together. This is just telling us that these fractions are out of 120, but then you do add the top numbers. So you've got 28 and 42, which is 70, and 20, which is 90. Okay, so the answer to that is 90 out of 120. Now there is a lazier way, a different way of doing it than looking at that. We know that total probability is 1, and there is only one actual outcome there which hasn't got at least one ball blue, which is green and red. Every other combination has got a blue in. So what you could have done, or rather than do all that, you could do 1 less first red, first green, second red. So you could have done 1 take away 30 120ths, 30 out of 120. Well, 1 is the same as 120 120s. Now when you're adding or subtracting, you can't do it until the bottom number is the same, which it is here. So I know that I'm measuring out of 120, and 120 take away 30 is 90. So you end up with the same thing, but with less working out to do. Doesn't matter which way you do it, really depends how your brain is wired, I suppose. Okay, let's take a look at the second question. And look at the context and fill it in. So Vivian has a fair cubical dice with its faces numbered from 1 to 6, and a bias dice for which the probability of throwing a 4 is 1 out of 3. She throws the 2 dice and notes whether or not a 4 is obtained on each dice. So the first group is the fair dice. So the chances of you throwing a 4 on a fair dice is 1 in 6. There's 6 numbers, all equally likely, so it's going to be 1 out of 6. So the chances of it not being a 4 is 5 out of 6. The other 5 numbers. For the biased dice, if the chances of it being a 4 is 1 in 3, the chances of it not being a 4 must be 2 in 3. They have to add up to 3 out of 3. And then it will be the same down here. So if I reach this point on my graph, then it's going to be 4 and 4, which will be 1/6 times 1/3. 1 times 1 is 1. 6 times 3 is 18. If I'm down here, then it's 4 and then not a 4, which will be 1 times 2 is 2. 6 times 3 is 18. If I'm here, it's not a 4, then a 4, which would be 5 times 1 is 5, 6 times 3 is 18, and if I'm here, then neither of them are 4s. Not 4, not 4, which would be 5 times 2 is 10 over 18. So if you want to work them all out, doing all the multiplying first, that's fine, no problem with that. Calculate the probability that both dice show 4. Well, we've done it up here now. It's 1 out of 6 and 1 out of 3. When you use the word and, you multiply, and you multiply 1 times 1 is 1, 6 times 3 is 18. Show the probability that exactly one dice shows 4. So for one dice, exactly one dice to shows 4, it's not the top, because that's both dice. It is 4 and not 4. Or, so I'm using the word or, which means I'm going to add. The first one's not a 4, and the second one is, which is 5 out of 18. And it's not the bottom one, because neither of those are 4. So there's only 2 ways to get exactly one dice showing a 4. Can't add them unless the bottom's the same. The bottoms are the same, so I can add the top numbers. So 7 out of 18 is the probability that exactly one dice shows a 4. Question 3. Each lunchtime, Paul either eats a packed lunch or he eats a sandwich bought at the snack bar. The probability that he eats a packed lunch is 3 out of 5. Whatever he eats for lunch, the probability that he buys a mug of tea is 3 out of 10. So the first part of this is to do with whether he's eating packed lunch or buying a sandwich. If it's 3 out of 5 packed lunch, then the chances of him buying a sandwich would be 2 out of 5. Second group are to do with tea or not tea. If there's a 3 in 10 chance he's going to buy tea, then there's a 7 in 10 chance he's not. So that's going to be 3 in 10, that's going to be 7 in 10. So we can work out the combinations. This is lunch and tea, which would be 3 out of 5 times 3 out of 10, which is 9 out of 50. This would be lunch and no tea. So lunch and no tea would be 7 3s are 21 out of 50. This is sandwich tea, which will be 2/5 times that, so that'll be 6 50s. And this will be sandwich no tea, which will be 14 out of 50. So those are all the possible combinations, and we want to know that he eats a packed lunch and buys a mug of tea. So packed lunch is 3 out of 5, and means times, and a mug of tea is 3 out of 10, which is 9 out of 50. Question 4. 2 bags contain some coloured balls which are identical except for their colour. One ball is taken at random from each bag and their colours noted. Probability of the selected ball from the first bag being red is 1 out of 4. So the probability of it not being red would be 3 out of 4. And in the second bag, the probability of the first one not being red is 2 out of 3. So the chances of it being red will be 1 out of 3. 1 out of 3, 2 out of 3. So the probability here to get to there, it would be red and red, which would be 1 times 1 is 1, out of 4 times 3 is 12. To get to here, it's going to be red, not red. Which will be 1 out of 4 times 2 out of 3, which will be 2 out of 12. Not red, red will be 3 out of 12. And not red, not red will be 6 out of 12. So both balls red will be 1 out of 12. 1/4 times 1/3. Only one ball red. Well, it could be red then not red, which is 2 out of 12, or add not red red, 3 out of 12. When you're adding, don't add the top, bottom, but you can only add the top if both the bottom numbers are the same. 5 out of 12. Question 5. A box contains coloured cubes identical except for their colour. The probability of choosing a red cube at random from the box is 5 out of 7. A bag also contains similar coloured cubes. The probability of choosing a red cube at random from the bag is 3 out of 5. Chris takes a cube at random from the box and a cube at random from the bag. Complete the following diagram. So the first group is for the box. Choosing a red cube is 5 out of 7, which means there's a 2 out of 7 chance that it's not going to be red. For the bag, the chances of choosing a red cube is 3 out of 5. So the chances of not getting a red cube is 2 out of 5. Now we're interested in neither of the cubes is red. So for neither of the cubes to be red, it means the first one is not red and the second cube is not red. So it's going to be 2 out of 7 for the first one, and means times 2 out of 5 for the second one, which is 4 out of 35. And that's the only combination where neither of them are going to be red. On the last question, this one's slightly different in that it's not fractions, it's decimals they're using for the probabilities. So we've got a factory with two machines, A and B, which it uses to make large numbers of a certain item. Machine A is used to make 60% of the factory's total output, and machine B is used for the remainder. The probability that an item made from machine A is rejected is 0.1, and the probability that an item made on machine B is rejected is 0.2. So the first pair of branches is the chances of what machine is being used. So machine A is used to make 60%. 60% as a decimal is 0.6. So machine B will be used 40% of the time, which is 0.4. Then we've got whether it's accepted or rejected. Machine A rejected is 0.1, so it's going to be accepted 0.9 of the time. Machine B is rejected 0.2, so is accepted 0.8 of the time. So that's put all the probabilities onto our table. The question, calculate the probability that an item chosen at random is accepted. So for it to be accepted, it's either machine A and accepted, or it's machine B and accepted. So we've got the multiplying for and we've got the adding for or. So A and accepted is going to be 0.6 times 0.9. or B unaccepted, which is going to be 0.4 times 0.8. 0.6 times 0.9 is going to be 9 sixes of 54 and two numbers after the decimal place, so 0.54, and this is going to be 4 eighths of 32, 0.32, and when you add those together you get 0.86. So the chances of a random item being accepted is 0.86. So the key thing to remember with your probability trees is when you're using the word and, you're multiplying. When you're using the word or, you're adding those probabilities together. And be careful with fractions.